Welcome everyone. So guys, in this video, we will be solving more questions about moles and the years. Actually, the questions I brought them from years from 2022 to 2020, and I included all papers. I mean March, November, and June. Okay. So before we start, guys, I hope you give like and subscribe. It will be quite encouraging for me to make more videos. So let's get started with the first question. Stop the video, read the question, take a look, and try to solve it by yourself. So look, guys, in this question, analyzing the hormone thyroxine gives the result shown. طيب, heating 0.5 grams of this compound with aqueous silver nitrate with AgNO3 produces 0.604 gram of silver iodide, gives us AgI. All of the iodine in the thyroxine sample converted to silver iodide. Okay, this is useful information. Actually, let's continue reading the question. Complete combustion of 0.5 thyroxine produces this amount of carbon dioxide and blah, 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 blah. Which molecular formula of thyroxine agrees with these values? So look, guys, first of all, I want to tell you that the AgI has a molar mass of 234.7. We will need this one later on. You can calculate from the values in data booklet. Okay, so yes, we reacted one of these formulas. It is the thyroxine formula. Okay, but which one we don't know so far. So we try to figure out from the information given here. Okay, so they say that when these compounds, or when thyroxine reacts with AgNO3, all iodine, all I molecules here will become AgI. So if this compound, this one, reacted with AgNO3, all I's here become AgI. So how many AgI we will get? We will get 4 moles. Okay, 4 AgI. Right. We know this. Look, guys, now what I'm going to do. From this equation, this is an equation. Okay, this compound plus AgNO3. So here we have 4 of this, I suppose, gives us 4 AgI. So we understand from this equation that 1 mole of this, gives us 4 of AgI. So 1 of thyroxine gives us 4 AgI. Okay, here we got AgI. Here we got thyroxine. I will say it is X. Or not X. Let me write THY. Okay, thyroxine. 1 gives us 4. Guys, how many of thyroxine we have? They say that heating 0.5 gram of thyroxine gives us 0.604 of silver iodide. Gives us how many moles of silver iodide? Let's convert this one to just 1 second. So as I said, 1 mole of this compound gives us 4 moles of AgI. But how many moles of this compound we used in the question? They said the complete combustion is 0.5 grams. So how many moles is 0.5? If we are talking about this compound, we will divide 0.5 over 776.6, and this one will give us, just give me 1 second, let's see what do we get here. We will get right, we will get 0.00064. Yeah, we will get this number of moles. Okay, this number of moles we used of thyroxine. So we use this number of thyroxine. So this number of thyroxine would give us X moles of AGI. Look, guys, this is the approach I am using all the time, and in solving these equations, I use cross multiplication method and dealing with more questions. So cross multiplication, first part from the equation, second part of the or the second step in here is from the question, and later on we do cross multiplication, cross multiply. So 4 times 0.00064 equal to x times 1. Okay, so in this scenario x will be 0.00257. What is this? This is mole of AGI formed if we use 0.5 of compound A, or option A, which is this. Right. I will convert this one, the moles, to grams and match it with this. If they are both identical, so this is the correct option. So this is grams, sorry, moles. If we want to convert them to grams, we should multiply it by the mass, right? Sorry, yeah, we have the moles here. We must multiply it by molar mass to find the mass. So the molar mass of AGI is 234.7. And this one, guys, will be what? Will be the answer here. The mass that we will get from this equation is, just 1 second, let me use my calculator. So we multiply 0.00257 times 234.7. Yeah, so we get almost the correct answer. It is 0.603. Okay, which is similar to the thing found here, thing that is made here. Not identical, but the same. So this is the correct option. And to make sure, guys, let me show you other options, and I will do them in the same way. So let's do question part B, option B, to make sure whether is my, to make sure if it's my answer is correct or not. So in part B, as we see, guys, if we use 1 mole of this and we reacted with AgNO3, all iodine here, I molecules become AgI. So how many AgI we will get? Ask yourself. We will get 8 AgI. So from this, guys, we will do cross multiplication once more. 1 gives us 1 of thyroxine, THY, gives us 8 moles of AgI. Okay. Yeah. So how many moles of thyroxine we use here? We do the same thing. We use, if we use 0.5 of thyroxine divided by the molar mass here, 1280.2, this one, guys, will give us, just let me make sure, if you divide them, you will get 0.00039. Okay, so just 1 second. 0.5 over 1280.2 Yeah, we get this number. So we use this number of moles of thyroxine. This number of moles gives us X. First part of cross multiplication is from mole ratio on the equation. Second part from the question. And third step or third part is cross multiply them. So 8 will be multiplied by this number. This one will give us 1 times X. Here X, right? So here in this side we will have only X. So X in this scenario will be just 1 second, let's multiply them times 8. Yeah, X is 0.0031. What is X? What do you think? X here, guys, is mole of AgI should be made if we use 0.5 of B, if the compound was B. So how many grams in this number of moles? What should we do? Definitely, we should multiply them by the molar mass. So we should multiply this number by 234.7, which is the molar mass of AgI to convert moles to mass. The number we get is 0.7 gram of AgI is formed if the thyroxine was B. But they told us that we get 0.6, not 0.7. So option B is wrong. And if you want to make sure about the rest of the options, you can do the same way as I did, and you will find different numbers. You can't find this option. You find this option only in case of A, so A is the correct answer. Guys, I strongly encourage you to do my steps with C and D, and you understand everything. Cross multiplication, guys, is secret method. It's the magic method, okay, by which you can solve any moles questions. طيب, let's move to another question. So, yeah, this question, which sample contains the most iodine? Which sample contains the most iodine? What do you mean by the most iodine, guys? The most iodine means how many moles of iodine. Okay, this is what they mean by the most iodine. How many moles of iodine? Yeah. By the way, the moles or the molar mass of I is 126.9. طيب, let's start with the first option. Option A, 1 gram of CaI2. Guys, we need to calculate. To solve this equation, we need the moles of CaI2. Sorry, the molar mass of it. Then we'll find the mole of it. Then we'll see how many moles of I2 in here. And we do the same thing for this. We need to know how many moles of I is found in each compound to know which one has more iodine. So for this question, we have to calculate first the molar mass of CaI2. Ca is 40 plus iodine, guys, is what's the molar mass of iodine? As we said, it is 126.9 times 2, and this one will give us 293.8. Okay, this is the molar mass of this compound. We have 1 gram, so 1 over 293.8 will give us what? Will give us the moles of this compound. So we got 0.0034. Okay, this is the moles of what? Of CaI2. We have this number of moles of CaI2. I2. Look, guys, here we have two iodine. Okay, we have two iodine, not one. So in this compound, we will have zero. The number of moles of Ca is, yes, 0.0034, but we have two iodine. So for iodine, it will be 0.0034 times 2 because we have I2. So this one will be 0.0068. This is the moles of, uh, yeah, this is the moles of iodine in here. Let's move to the next question. And the next question, we need to find the molar mass of Ki. So the molar mass of Ki, guys, is 165.9. I calculated before. We divide this number by 1. So 1 over 165.9, which will be, yeah, 0.0060. Should we multiply here by 2? I hope you understand the idea. We shouldn't. Okay, so when we have 1 mole of Ki, or when we have this number moles of Ki, then we have 0.0060 Ki and 0.0060 K. Okay, moving to the next one. NaI, the molar mass of NaI is 149.9. To find, this is the molar mass. We divide mass over 149.9, and this will give us 0.0067. Okay, so until now, option A seems the correct one. Let's see the last one, guys. The last one is NH4I. Molar mass of this guy is 144.4. Sorry, 0.9. Yeah. So we divide 1 by 144.9. Guys, the mass is 1. All the masses here are 1. This gives us 0.0069. Wow. Yeah. So for this reason, guys, question 3, the correct answer for question 3 is, yeah, it must be D. The correct answer. This one has the largest number. Hope you understand what I'm talking about. Next question. A student reacts 1 mole of copper with concentrated nitric acid to produce 1 mole of copper nitrate. 1 mole of copper reacted with the HNO3 to produce 1 copper nitrate, CuNO3 by 2, and 2 mole of water plus 2 H2O and substance X plus X. So no other products are formed. Substance X does not contain copper or hydrogen. Okay, so what it is X? X has no hydrogen or copper. Let's see. How do we solve such a question? Yeah. Look, guys, in this part, when I see such a question, or when I first saw the question, I just noticed that here we have 4 hydrogens, 2 moles of hydrogens, and the only source of hydrogen here is this. So because you have 4 hydrogens, I must multiply this guy by 4, right? because we have 4 hydrogens. So here we have 4 hydrogens and 4 NO3s, right? 4 NO3. 2 of them are cancelled with this, so here we 2 NO3 remained. 2 NO3s. That means we have 2 nitrogen, 6 oxygens, right? And here we have 2 oxygens. So in here we have 2 oxygens, 2 by oxygen, 2 oxygens. So 2 nitrogen and 4 oxygens remained. We remove 2 from here. Yeah, so the only one that gives us the required ratio is D. So I would say it is a plus, yeah, plus NO2. Okay, plus NO2. But actually 2 of them, yeah, 2 NO2. Yeah. So the correct answer is D. The correct answer for this is D. طيب. Here we have another question, which is the tricky question, I think. Yeah, this one was the tricky question. Stop the video, guys, and have a look. So compound X has 3 elements, CHO. 2 grams of this X produces 4 grams of CO2, 1.63 of water when completely combusted. طيب. What's the empirical formula of X? Look, guys, when X, let me draw it like this. When X is combusted, so combustion, we must have water, oxygen. We get H2O and we get CO2 because we have complete combustion. Okay, طيب, nice. 4 grams of carbon dioxide are formed. Guys, in 4 grams, how many moles of CO2? How many moles of CO2 in 4 grams? So we divide mass of CO2 over a smaller mass. CO2 molar mass is 44. Carbon is 12 plus oxygen 16 times 2, 44. So it is 4 over 44, right? Yeah. So let's use our calculator. 4 over 44. And so, yeah, for this one, we got 0.09. Okay, and for H2O, we got 1.63 grams of water. So we once more we find the moles of water. It is 1.63 over 18. Wow, which gives us the same, number. Okay, we get 0.09. 0.09. Okay. So look, guys, this hydrocarbon must have double hydrogen atoms when compare it with C, with carbon. Because look, guys, any hydrocarbon, when you combust it, let's say that you are combusting what, C4H8, for example. You are combusting this one. So we get 4 plus O2, 4 CO2 plus 4 H2O. Okay. Number of moles in the front of are the same. The number of moles are the same. But here we have two hydrogens, right? Okay, we get the same number of moles, I mean. Here we have same number of moles, 4 and 4. But don't forget, in the original compound, we have 8 hydrogens and 4 carbons. The same scenario takes place here. The same scenario occurred here. We get the same number of moles. Here as well, we get the same number of moles. But my original compound has more hydrogen, double number of hydrogen. Let me give you another example. C8H16. Okay, so we'll get 8 CO2 plus 8 H2O, but still we have double number of carbon. The same number of moles, sorry, the same number of moles, 8 and 8, but in original compound means we have double number of hydrogen. What I want to say is, according to this, we can ignore option A, because A is saying that the ratio of carbon to hydrogen is 1 to 1, and this is wrong. It must be double. Yeah. So according to this, guys, we can ignore option A because C and H have the same number of moles in here, and B as well. C, carbon and hydrogens both have the same number of moles, so we ignore these two things. Okay, so C and D, as we see in C and D, hydrogen is more hydrogens are found. Okay, the more ratio is not the same. Hydrogen is double. So which one of them is correct? Which one of them is correct? Right. Let's see. Look, guys. I would suppose that C2H4O is the correct option. So if I burn this one, we will get how many CO2s? We will get 2 CO2, right? Because we have 2 carbons. How many H2O? 2 H2O, right? Because here we have 4 hydrogens, so we still have 4 hydrogens here. Balancing the oxygens here is not that important, actually. Okay, balancing the oxygens is not that important. Look, guys, if we burn 1 mole of this, if I burn 1 mole of this, we will get 2 moles of CO2, right? Right. How many moles of this we burned, actually, in the reality? How many moles of this guy we burned? What do you think? We burnt 2 grams. So I will divide 2 by the molar mass to find how many moles. What's the molar mass of this? 2 carbons. So 2 times 12 plus 4 times 1 plus 16, which will be what? Which will be what? wait, which will be what? Which will be 44, right? Yeah, which will be, just 1 second. Uh, yeah, as we said, he will get 24 plus 4, which is 28, plus 16, it will be 44. So this is the molar mass, 2 grams over 44. So 2 over 44 will be 2 over 44, 2 over 44, it will be 0.045. So yeah, if we use 0.045, how many moles of CO2 will get? I would suppose it is X. The next step, guys, will be cross multiplication, as we said. So 2 times 0.045, which equal X, and X will be 0.09. This is the amount of moles of CO2 would be produced if we use this compound. The amount of CO2 produced in the question was 2 grams. So, sorry, was 4 grams, right? So how many moles of CO2 produced? As we said, we divide 4 by molar mass of CO2, which is 44. We will get 0.09. So these two numbers match each other. Option C is the correct option. Look, guys, in the questions of moles, you have many methods you can solve the question correctly. But for me, guys, I prefer using cross multiplication method. So the first part of it from the question, from the equation, mole ratio of the equation, or you can use mass ratio as well. The second one, it must be from the question, and then cross multiplication. This is the best method we can use. طيب, let's continue solving more questions. So just 1 second. Yes. Look, guys. Yeah. How many moles of oxygen are needed to burn 1 mole of ethane if the products of the reaction are only H2O and C? So ethane, it is C2H6 plus oxygen. This is combustion reaction. We get carbon plus water. Balancing of this reaction, guys, is quite easy. We just take the number beside the carbon, we multiply it by C or CO2, depends on what we have here. The number beside the hydrogen is divided by 2 and will be multiplied by this, so it will be 3H2O. So here we have 3 moles of oxygen. Yeah. So here we need 3 moles of oxygen. So here we have O2, so we must multiply it by 1.5 O2 moles required. So this is option A, not B. طيب, let's move to the next question. Which sample contains the same number of the named species as the number of molecules and 35.5 grams of chlorine? Which sample contains the same number of named species as the number of molecules and 35.5 of chlorine? So how many molecules and 35.5 of chlorine? Look, guys, chlorine is Cl2. Okay, not Cl. Chlorine molecules are Cl2. So to know how many, to know the numbers, we should find the moles, okay? To compare the number of molecules, we are supposed to find the moles. So how many moles of Cl2 we got here? It is mass 35.5 over, yeah, mass over molar mass, which is 71 molar mass of Cl2, because we have two Cls. This would give us 0.5 mole of Cl2 molecule, 0.5 mole. Okay, so which type of these has 0.5 mole? The question look like this. Right, let's see option A. Atoms in 16 grams of sulfur. Look, guys, sulfur has molar mass of 32. So here we have 16 over 32, which give us 0.5 as well. So yes, this is the correct option. Okay. Yeah. Let's see this one. Here we have 0.5 mole. Next part of the question, or the second option, atoms in 23 grams. So we have 23 grams over 23 as well. So here we got 1 mole, and this is wrong. We need only 0.5. The next option, which is C, ions in this of potassium chloride. KCl has 74.5 molar mass, so mass 0.5 over molar mass. This will give us 1 mole. And the next one, molecules and 88 grams of carbon dioxide. It will be 88 over 44, the molar mass of CO2. Here we got 2 moles. Okay, so this is very simple questions. طيب, let's move to the next question. Mixture R consists of 1 mole of C3H6 and 1 mole of C4H6. Okay. What is the minimum number of moles of oxygen needed for complete combustion of R? So R has C3H6 and C4H6. Look, guys, C3H6 plus oxygen. This is, guys, complete combustion. So we get CO2 plus water. As I told you, for balancing, just the number beside the carbon is multiplied by CO2. The number beside the hydrogen will be multiplied by H2O, but we divide by 2, by the way. So in total, how many oxygens we got in here? So here we have 4 in total, and here we have 3. So it is 7 oxygens. So it is a 3.5 O2 will be here. For the next one, C4H6 plus O2, this will give us, this will give us CO2 plus H2O. So the number beside the carbon multiplied by this, the number here will be divided by 2 and 3H2O. So in total here, guys, we have 8 oxygens here, and here we have 3 oxygens. So we have 11 in total. 11 oxygen atom. Here we have O2, so we say 5.5. Yeah. So times 2 will be 11. So they need the number of moles of oxygen. So we say 5.5, the total number, 5.5 plus 3.5. Okay. But just 1 second. So we got a mistake in this one. Here, guys, we have a 3 CO2s. Sorry, let me correct it. Here we have a 3 CO2s. So from this part in total, we will have 6 oxygens. Okay. And 3 plus 6, it is 9 oxygens. So here we have 4.5 O2. So yeah, 4.5 plus 5.5. 4.5 plus 5.5, which will be 10. It is option C. 10 oxygens we have. Moving to the next question. طيب. Sodium peroxide, Na2O2, let me use different color. Na2O2 is used to absorb CO2 from the atmosphere, blah, 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 and release and close such. We have this reaction. Which mass of sodium peroxide, mass of this one, will be required to remove 2.4 decimeter cubic of CO2 from the atmosphere at room temperature and the pressure. طيب. Which mass of sodium peroxide? So in this equation, we talk about sodium peroxide and CO2. Sodium peroxide and CO2. طيب. Sodium peroxide and CO2. Look, guys. Yes. So I will convert the volume here of CO2 to moles. So I would say mole equal volume over 24. This will give us how many moles? Unknown. 2.4 over 24, which is equal to 0.1. So this is, guys, the moles of Na2O2. طيب, okay. We found the moles of Na2O2. Sorry, the moles of CO2. طيب. Required for this process. So we know that 2 moles of Na2O2 and CO2. 2 moles of Na2O2 required to react with 2 moles of carbon dioxide. We need to remove 0.1 from carbon dioxide. So what's the number of moles of Na2O2 required? Cross multiplication. But now both of these have the same number of moles. That's why, guys, this one will be 0.1 as well. Okay, so we found the moles of Na2O2 required to remove that amount, this amount of CO2. So we need the mass. Mole equal to mass, which is unknown, over the molar mass of Na2O2. Na is 23 times 2 plus 16 times 2. This one will give us 46, and 46 plus 32, which give us 78. This is the molar mass. So here we have 78. X will be 7.8, which is C. Okay, so the question is over. The question is over. طيب. We move to the next one. Guys, for this question, you need to stop the video for a while, having a look on it. It's a little bit confusing. So let's see, what do we have here? Calcium oxide and magnesium sulfide each react with acid. طيب. Okay, these are reacting with acids. Yeah, to produce CaMgH2S. A mixture of these two compounds, يعني a mixture of CaO and MgS react exactly with 0.125. So guys, X has MgS and CaO. طيب, this mixture react with 0.5 mole dilute HCl. Okay, the amount of hydrogen sulfide formed is this. This is the amount of H2S that we get. The amount of H2S that we get. What the mass of calcium oxide? What the mass of calcium oxide? We need the mass of calcium oxide, and we have only one thing given. Okay, or two things actually, the mass of H2S, and we have also the dilute hydrochloric acid. This is the amount required to react with both MgO and CaO. Look guys, from the second equation, we see that 2 moles of H of the acid give us 1 mole of H2S, right? 2 moles of acid, 2 moles of H plus give us 1 mole of H2S. طيب, okay. So the amount of hydrogen sulfide formed is 0.025. 0.025. This is the amount of H2S that is made. So what is the amount of acid required to produce that much of H2S? It is X, unknown. Cross multiplication. 2 times 0.025 equal to X times 1. X will be 0.05. What is this? This is the amount of H plus in moles طبعا gives the H2S. The H2S in the question. The H2S in the question. طيب. Yeah. 0.05. So we can say that the amount of H plus required in here in this equation, the amount of H plus required in this equation was 0.05. And all the amounts, the whole amount of HCl reacted is 0.125. So we say 0.125, the whole amount we have, minus 0.05 required to react here. This will give us 0.075. So this is the remaining of H plus that has been used in the first equation. Okay, this is the amount has been used in the first equation. طيب, don't forget we need the mass of calcium oxide. CaO, guys, 1 mole of it reacts with 2 moles of acid. 1 mole of CaO reacts with the 2 moles of acid. طيب, and what do we have as well? We have X of CaO would react with 0.075 of the acid. So what will happen here is a cross multiplication. 2 times X equal to 0.075 times 1. So X will be 0.075 over 2, which is, just let me use my calculator. Which is 0.0 it's not like this. Wait. The answer 0.075, 0.075 over 2. Yeah, it will be 0.0375. What is this? This is the moles of CaO. We need the mass of CaO, so we know we complete here, we continue here. Mole equal to mass over molar mass. The moles is 0.0375. Equal to mass, guys, is unknown. Molar mass of CaO is, yeah, Ca is 40. Ca is 40 plus oxygen is 16, so it's 56. So if you multiply these two numbers, you will get 2.1, which is option B. Okay, so just let me check. Times 56. So yeah, this 2.1 gram. So this is the correct answer.